Good afternoon, everyone. Welcome back to the French Institute of Estonia podcast, a monthly podcast dedicated to innovation, technology, and the link between France and Estonia. Today, I am happy to welcome Ahmed Chemori for our winter edition. Ahmed, you are a senior research scientist and author in automatic control and robotics for the French National Center for Scientific Research, or as we call it in French, CNRS, at the Montpellier Laboratory of Computer Science, Robotics and Microelectronics. You are also a senior member of EEE. You have a strong link with Estonia, as you were the laureate for the PhD program Parrot with Mrs. Maria Krusma in 2015, and you are ongoingly contributing to a lot of exchange of knowledge through events and scientific conference in Estonia and in France. The first question that I want to ask you is very simple. Could you describe to us what actually is a robot?
Thank you very much for this first question. So there are a lot of definitions of robot, and actually the simplest one is the following. So a robot, it's a device composed of mainly four components. The main first components is the articulated mechanical structure. Then to be able to move in its environment, robot needs actuators, need motors. And then it will be able to do the perception of the environment. A robot needs sensors. This is the third entity. And the last one, it's the intelligence. And we can find inside the control system of the robot that can be a microcontroller, a computer, or an automated programmable system.
And so where does the term robot come from?
Yes. So the robot term was coined like around 1921 by the fiction science writer Charles Čapek from the Republic of Czech, and it means hard work.
Hard work, yes. I think we've seen in a lot of fictions that robots are usually linked with this kind of hard physical work. You've been invited to Gustav Adolf in Tallinn. We've seen during this conference that children have actually a lot of strong reaction to seeing a robot in motion and to hearing about it. The first thing that comes to mind when thinking about robotics is strongly linked with some kind of emotions, be it fear or affection. Robots are now in the general culture, and they are inducing a lot of reaction in humans, in children, in everybody. Is it easier to be a scientist or an engineer in the robotic field when it comes to public outreach? That is, making sure that the public is aware of the latest research in the field?
Yes and no. Yes, it's easy, but as you know, robotics today is more and more in our society. Then we have a lot of robots around us today. And for instance, what I have seen recently here in Estonia is delivery robots that we can across in the street, and there are a lot of here in Estonia. And also we can find other robots, what we call them service robots, and they are present mainly in hotels, airports, and so on. And they interact with humans. Sometimes you arrive to a place, you need one information, so there will be a robot that will be in face of you, and that can answer all your questions and give you the needed information. So for the public, for sure, it's some of them it's difficult, but for children, I think they are very, very fascinated by these robots.
And for you, does this element act as an inducer for your studies of robotics? How did you came to actually study robotics?
Also, this is a very good question. So it goes back many years ago when I started my studies at the university. So at the beginning, I was very fascinated by computer science, by informatics. But finally, I started my studies first in mathematics. Then I did electronics. And in electronics, there has been three options. So the first option is microelectronics. The second option is telecommunication. And the last one, it was control. So I started studying electronics, and I started learning about control systems, which is automatic control in theory. And when I started my master thesis, I worked on control of a biped walking robot. And it was the first time, it was like around 2001, the first time that I started learning about robots from the control point of view. After finishing my master studies and after finishing this training period on control of biped walking robots, I started a PhD. And the topic of the PhD was the continuation of the master thesis topic. And I will continue working also on control of biped robots. For 3 or 4 years, I was fascinated by these walking machines. And I did a lot of efforts to propose new control schemes for this kind of systems. And in the end of my studies, I did also another postdoc, and I did a postdoc on control of drones, of planar, vertical takeoff and landing aircrafts. And I did also some control schemes like model predictive control. And then I started working in the lab in Montpellier afterwards.
Whoa, that's a lot. So during your research, you've been working with a lot of countries as a visiting researcher. Among other, Norway, Japan, Switzerland, Estonia, China, Mexico, Thailand, and so on. How would you define their respective approach to research in robotics? And what are some of the fondest memories you have from those times?
Yes, I think research in robotics, it's different from one country to another. And it depends on the country. Some of the countries, they did a lot of research in theoretical aspects, because actually, if you want to do research in robotics and you want to go until the end, until the application of conducts the research, you need to do experiments. And sometimes these experimental setups, they are very expensive. So some countries, they stop at the level of simulation. Like if you take Tunisia or Algeria, so most of the studies they have been done in simulations only. Other countries like Japan, it's the inverse. So the first step, it's experiments. They start by experiments. They did a lot of experiments, and all the conducted research in robotics are applied. And for the fondest memories, I remember a few years ago, I have been in Thailand. And at that time, the Thailandese professor proposed us to go to a restaurant. And he proposed us two options, to go a Thai restaurant or a Japanese restaurant. And in Thailand, this Japanese restaurant was equipped with only robots to serve the persons in the restaurant. So, and it was fascinating to see. I mean, you ask the food that you want to eat, and a few minutes later, you have a robot that brings you the food. So this was a very, very good experience for me.
And so those robots are called service robots.
Service robots, exactly. Yes, that's it.
What are the difference between a service robot and an industrial robot?
Yes, there is a very big difference. Actually, if you look to the history, it starts with industrial robots. An industrial robot, it works in an environment, and no human is allowed to go inside this environment because it's very dangerous for the human. Now, for service robots, the robot will be able to interact with the human, and sometimes it's not just the interaction through exchanging maybe words or signs or gestures. Sometimes there is physical contact between the robot and the human. And the problem here, if we use an industrial robot, it's very dangerous for the human. At that case, so the idea is to reduce the power and to increase the security before we can use this kind of robots in this field, service robotics. So there is a big difference. I mean, industrial robot, it has very high power. The service robot has a low power and also a very, very increased security to be able to interact with the humans.
What are you talking about when you talk about low power in service robots, for example?
It means the power of the actuators, of the motors of the robot. So, I mean, in industry, we use powerful motors in the articulations of the manipulator, for instance. However, in service robots, we reduce the power, the energetical power of these motors used in service robots.
Okay, so that's very engrossing. And regarding robots that are used in medical care, would you say that this is the future of healthcare?
Yes, actually, we started using robots in healthcare many years ago. I said last decades, for instance. And nowadays, they are a lot used in healthcare. I will give you just two examples for medical applications in general. So the first example, it's the robots used for surgical applications. So nowadays, we can find a lot of hospitals all over the world equipped with these kind of robots to help the surgeon to do some interventions on patients. This is one example. The other example for healthcare also, it's the field which is also a field very interesting, and especially for the future also, it's the what we call wearable robotics or rehabilitation robotics or exoskeletons. Nowadays, exoskeletons are more and more present in our society, and one of the four main applications of these exoskeletons is medical applications. Like, for instance, for rehabilitation, they are a lot used nowadays to do rehabilitation or to help the doctor doing this kind of tasks.
But when we think about exoskeleton, we also think about pop culture and Iron Man. Weren't these exoskeleton used first in the military?
Yes, exactly. First of all, if we go back to the history of development of exoskeletons, one of the first exoskeletons developed in the world, it was in the US, and it was like Iron Man. It was like a huge exoskeleton that weighs 680 kilograms, and that has a lot of degrees of freedom, and that can increase considerably the power of the human. So it was developed like around the 60s. Nowadays, after that, it has been used. The exoskeletons have been used a lot for military applications for a certain decades. But recently, we have mainly four main applications of these exoskeletons. So the first application is the military application, where they have been historically developed first. But we have new three emerging applications. So the first one is the medical application or healthcare application. Then we have the industrial application, in fact, to help the workers in industry to carry in very heavy loads. So nowadays we can use exoskeletons. And the last application is for leisure application for skiing, for instance. Nowadays we can find exoskeletons also used to help human for this kind of activities.
That's awesome. I would very much like to try that. Technology that is a little more nature-centric and not only user-centric or tech-centric is getting more and more visible. One of the conference you are going to give tomorrow is related to biomimetism in robotics. Could you lead us through this concept?
Biomimetic robotics, it's a very, very interesting field of research in robotics. So it contains a lot of aspects. One of the aspects is to be inspired from nature to design and control a robot. One of these aspects is the morphological inspiration. So we can be inspired from humans, from animals, from insects, from birds to construct robots that have exactly the same morphology of of the nature. And we have also other aspects of bioinspiration. It can be, for instance, the human brain. The human brain, nowadays, we have what we call artificial neural networks. that's used to mimic the functioning of a human brain. And they are a lot used for artificial intelligence, for instance. We can find a lot of bio-inspired robots. So we can find like flying bio-inspired robots like birds. We can find like bio-inspired underwater robots like fish robots or like turtle-like robots, for instance. And we can find also other examples. So we have a lot of examples of bio-inspired robots like quadrupeds, for instance, inspired from animals. The example of the robots that we have used for the demonstration in Gustav Adolf High School, it was like a dog robot with 4 legs that can move and that can do a lot of tasks and very close to the human.
And that leads us to UCAT, which is actually a project that is very much ingrained into Estonia's robotic history and your own. Could you talk to us a little bit about these robots?
Yes. UCAT is an underwater vehicle. It's a bio-inspired underwater vehicle that has been designed many years ago. It was around 2012, 13, something like that. I started cooperation with Center for Biorobotics of Taltech here in Estonia in 2015. And from that date, we start working together jointly on the control of this vehicle, UCAT. What is UCAT? So UCAT, it's a biomimetic underwater vehicle equipped with 4 fins. So instead of classical propellers, we used here fins to actuate the robot. So it has 4 fins. It has some sensors also to be able to ensure the perception of the environment around UCAT. UCAT is equipped with some sensors like a depth sensor to estimate the depth of the vehicle underwater. UCAT is equipped with an inertial measurement unit that can measure the angles and the angular accelerations of the vehicle in real time. And also it is equipped with some distance sensors. And lastly, we have some hydrophones used in UCAT to be able to control the vehicle with acoustic underwater signals.
When we listen to you, we realize how much physics and mathematics goes into a robot. Is it a big part of what you are actually doing day to day in your lab when you're trying to make a robot or studying the reaction of a robot?
Yes, exactly. So in my case, I'm interested in control of this kind of vehicles, and to do this task of control, for sure, we are obliged to study the physics. One of the steps studying the physics concerning these robots is, for instance, the mathematical model of motion, the dynamic motion. It is what we call a dynamic model or hydrodynamic model. So before we start developing control schemes, we need to model the dynamic behavior of the vehicle underwater, and it needs to study this hydrodynamic behavior and to transform this behavior in terms of equations. These equations are representing the dynamic model that represent in the best way to have the equivalent of the real behavior of the vehicle. And then we try to use this in the control design to be able to control the vehicle. Since if you have a dynamic model, you can estimate how the behavior will be of this vehicle. Then we can try to adjust our controller depending on the behavior of the vehicle.
Could you explain very simply what you mean by control?
A controller in whatever the robotic system is, as I explained before, a robot is composed of 4 main components. So the mechanical architecture, the sensors, the actuators, and the control system. So the control system is the heart of the intelligence that control the motion of the vehicle. So what is control? So control, it's the design of an algorithm that can be implemented on the control system of the robot, and that is able to to control in real time the motions of the robot to do the specific task intended for. So if you are interested in controlling of a mobile robot, for instance, to go from one point to another, you need to design a control scheme. You write the algorithm, you implement it on the vehicle, and then when we run this algorithm, it will control the motion of the vehicle through the choice of the signals that we send to the motors of the robot to track exactly the predefined trajectory to move from one point to another.
Okay, so you mentioned AI. We often hear people calling AI a bot. Do you think that there is a strong difference, or is there a strong difference between AI and the robot? And what do AI change to the future of robotics?
Robotics and artificial intelligence are two fields. They are different. So in robotics, we are interested in design of robots and designing control algorithms to control the motions of the robot. And we can do it without artificial intelligence. Now, if we have artificial intelligence, it is possible to adapt our control schemes, for instance, to enable the robot the possibility to adapt to an environment. So you put the robot in an environment and he can use this intelligence in its evolution in this environment. For instance, if you design a robot and you control it in a controlled environment, and then you move the robot from this environment to another one, you can use the intelligence to detect this new environment and to adapt to this situation. One of the application that I have used previously using artificial intelligence, it was on UCAT. And we designed some controllers, and the idea was to control this underwater vehicle for a specific task of cooperation between UCAT and a diver. And the task that we imagined at that time, it was to do a diver following. So we used different control signals. One of the signals, it was first the acoustic signals to track a pinger underwater. The pinger was held by the diver, and UCAT was using his hydrophones to detect the position of the diver and to follow it. Then we try another signal, which is the camera. So at that time, if the diver is in the field of view of the camera of UCAT, we used artificial intelligence to detect the diver itself. So we used deep learning and the neural networks, artificial neural networks, to learn a diver picture in the video, and then to detect if there is really a diver or no, and then to decide to follow in real time the diver. I think that a robot in software, it's something which is completely different from a robot in our field. In our field, we have this physical dimension. We have this mechanical part of the robot. In a software, so it's a program. We called it also a robot, but really it's not a robot, like it's an avatar. And in our case, it's different, where we have this physical dimension of the robot.
And finally, for you, what is the next frontier in robotics? What are the challenges facing robotics in the near future and in the far future?
Yes, as you know, robotics is progressing very, very fast, and especially last years or last decades, with the increase of this computing capacity, the new computers, very, very powerful computers, and this artificial intelligence that comes also inside this field. So it's progressing very, very fast. For the future, first of all, concerning me, the next step after UCAT, I think we will work on a new robot called amphibious robot. And it's a robot that can at the same time behaves on the earth, and it can go inside water, and it deploy a part of the wheels of the robot to become fins and use them to control the vehicle underwater. So this is the next step concerning me. Now concerning robotics, there are a lot of challenging fields in very, very fast progressing nowadays, like micro-robotics, where we have to design very, very small robots, sometimes send them inside the body of the human to do something like an intervention or like to do surgical applications and so on. And also we have the field of exoskeletons. Nowadays we have more and more exoskeletons, and they are more and more present in the society, not only in medicine, but also for healthcare and also for even leisure applications.
And to end this podcast, we are going to make it an habit to finish on a French note. So I'm going to ask the question in French, and please answer in French if you'd be so kind. Quel serait votre conseil pour un jeune, un adolescent ou un enfant qui pense à orienter sa carrière vers la robotique?
Une très bonne question pour finir et pour répondre. Donc, le domaine de la robotique, c'est extrêmement riche. Donc, j'encourage les enfants de jeune âge pour s'intéresser à la robotique dès le jeune âge parce que dans le futur, il y a plusieurs débouchés. En fait, si on travaille dans ce domaine-là, donc il y a principalement deux voies ou deux débouchés. La première voie, c'est l'industrie. Donc, il y a de plus en plus de sociétés, d'entreprises, d'industriels intéressés à utiliser des robots. Et la deuxième voie, c'est la voie académique, donc où on peut faire soit l'enseignement de la robotique à des élèves à différents niveaux, ça peut être le lycée, l'université, licence, master et même doctorat. Et puis après, il y a le domaine de la recherche qui est très très fascinant. Il y a énormément de problèmes qui restent ouverts malgré le développement très très vite qu'on a eu lieu récemment en robotique. Il reste encore beaucoup de problèmes ouverts. Il reste encore beaucoup de problèmes à résoudre en robotique et bien évidemment pour servir la société et l'humanité.
Merci beaucoup, Ahmed. Thank you so much, Ahmed, for this very interesting podcast. I hope that some of you have no vocation to work in robotics. And for us, we will see you soon in Paris or Tallinn.
Thank you.